Hello. I would like to discuss with you how to write a lesson plan. This is especially for PGCE students and NQT students. I've chosen electrolysis to show you how to write a lesson plan because it's the most difficult topic. And PGCE students, when they hit the floor in October or November time, this is the topic that they have to teach. And it can be quite challenging because to be honest, electrolysis concept is quite difficult for students to grasp, and there are so many new terms. Now, the lesson plan template that I have used in my lesson is from uh, scienceteacher.co.uk. The template is very well laid. So it's like, what is the activity that you're going to engage your students with when they enter the classroom? How are you going to check their prior learning? How will you introduce the new concept? How will you build on new concept? And then this is where building is where we practice this new concept and build on it. And how are the students going to apply this new concept? So here, uh, the columns are very well laid. How are you going to assess your students' engagement and prior learning, etc.? What are you going to do? Why you are going to do that activity? How much time you're giving to each activity? Now, when my students enter the classroom, I would be giving them a starter activity. So they would be doing this starter activity because I'm aware that my students do not understand how to count the number of atoms. Actually, this is a skill, and not many students can do it. So it needs constant practice, constant reinforcing. You will notice many students in year 10 do not know the concept of periodic table. They will not know that copper is a metal. So you will be surprised that as a PGC student that there are so many learning gaps which you need to keep addressing. You need to keep recalling what they learned previously and keep on teaching new concept as well. So it's like um, going throughout. You are going, it's like repeating, lots of repetition. It's needed because students cannot remember many things. So I know counting number of atoms is a difficult skill. In fact, they struggle to understand symbols. They struggle to understand the numbers, the subscript and the coefficient concepts. So constantly it needs reinforcing. You need to keep checking their work by questioning them. So you can choose the students you are going to who are going to answer you how to count the number of atoms. You can use lolly stick method to check to choose your students. You can practice pause, bounce, and pounce technique with your students. Now, when I plan my lesson, I look at the scheme of work. From the scheme of work, I come up with the learning objective. I also look what are the keywords in the scheme of work that are included in my lesson plan. So, how will once you have your learning objectives, you're going to think about now learning outcomes. There is difference between learning objectives and learning outcomes. Learning outcomes are measurable, so you can Google it and find it in more detail, or success criterias as well. So where you are able to measure students' progress in the lesson. So you can have your own outcomes like this. If the student is able to identify ionic compound, that means he has made some progress in the lesson. He's the student If the student is able to describe the process using the keyword, that's a good process, good progress. So each learning outcome each progress is also related to the activity that is going to help you measure the learning outcome. So you must include that in your learning outcome. Otherwise, many times these are the simple thing. If you don't include it, like activity, if you don't include this activity, you might get told off for it. So just be careful and include those activities. And here, include in your lesson plan how are you going to differentiate for your students. So when you include that, you're checking the box differentiating using constructive approaches, teaching standard 5. You check the work of your sense student, ask them questions, provide them with your slide printouts, glossary. Pixel has excellent knowledge organizers. You can give them a knowledge organizer. You can provide them with the key points. Then you can give a TA printout of electrolysis process from BBC website and encourage TA to help students with spellings and words, pronunciation. You can go to Google Translator for your EAL students and translate to the words in there or sentences in the language which EAL student understands. So if you can include all that differentiation in your lesson plan. Always praise your students for effort. That also you can write, when you assess your student, you praise them. So it takes another teaching standard. um, Now, you will need some kind of evidence in student's book where you have put a question and the student has answered. So prepare a list of students you are going to ask and which student you are going to ask a question. So for example, I asked a student SAS who is a sense student, and I asked him a simple question. So then I asked another student whose predicted grades are 7, and I asked him a slightly different question. So that's evidence for you where you are stretching pupils of different background. Ensure, whenever you write anything on the board, you are writing correct answers on the board. For students, you're also writing, because when you verbally say, not all students are able to grasp it. Some students actually want to see it. So you will need to write your answers on the board too. Or you can have slide work, but I prefer actually writing, because I find my students are more engaged when I write on the board. So prior learning and check. You are going to check their students' prior learning, because it's electrolysis topic. I'm going to check my students, are they able to identify what are ionic compounds. So I give them a hint. Ionic compounds are formed between metals and non-metals. Can they now identify which one is metal and which one is non-metal? And you will see students struggle here in identification of compounds. Which one is metal, non-metal? As I told you, it needs constant reinforcing. They keep forgetting the symbols of the elements. It needs constant reinforcing, and you need to constantly do it. So why I have included this activity, I've mentioned it. And then I also understand that students struggle to, they think that calcium is non-metal, because you see, calcium, one of my student once questioned me, miss, why we say calcium is a metal. My finger has calcium and the fingernail has calcium. If it was a metal, it would be attracted to a magnet. You can see, this kind of questions come one to one when you go to students and you ask them. So they have these kind of concepts in them, which are from built by their own observation. So then you need to address such concepts one to one, because I asked the question. It was during one to one session. I found it very interesting when he asked me more in detail, and this was actually very low ability student. And I was really surprised that he was made to think through questioning, and then he asked me such a question. So it was impressive. So then you can include such things like, you have understanding and to how students learn the subject, understanding of development in the subject, how students are grasping it. Introduce new language, new knowledge. So how are you introducing this knowledge to your classroom? It's very important. So I generally, when I explain electrolysis process, I use very simple explanation. Like, I use actually a story. I use a storytelling method where I tell them 20 years ago when my husband proposed me when we were at the university. He gave me a stainless steel ring coated with platinum, etc. I just come up with the story and tell them. It hooks them. And you can then, if you know the environment of your class, ask a low achiever student what would they like to quote, which precious metal will they like to quote a spoon with, and why did they choose it. And that will further give you opportunity to discuss the concept in detail, because I remember once it led to the discussion of understanding that the most expensive metal is palladium, and it's used in the cars to make catalytic converters. So sometimes the discussions can go to a different level, because you can include that in your lesson plan, then in your reflection then. So when I introduced the electrolysis process, I used a video to introduce this concept, because I know that students find it very hard to understand molecules or atoms because they can't see it. It's a very abstract concept. Like, when I constantly tell them that particles are so small, I tell them a tip of pencil can hold 5 billion hydrogen atoms. So atoms are so small. I try to bring these concepts to them in a way like, they can understand it's happening there. The electrolysis process is happening, but the particles are too small. We cannot see them. So the animation helps. Video lessons sometimes help. So this shows that students have different ability to, and therefore have used different method to teach this lesson. For example, when I was teaching a lesson on atoms one day, and the student asked me, "Miss, are atoms alive?" So these are the concepts which actually sometimes very low ability students ask you, and they are very refreshing questions actually. You need to keep watch on this. You can include these type of rich questioning in your reflection if you come across students asking you such questions. Uh, and when I was, for example, now coming back to electrolysis, when I was teaching electrolysis, I generally pause and then I ask questions, reinforce the keywords, explain them the origin of the keywords, include that in your lesson plan. Include misconceptions on electrolysis in your lesson plan. So go on Google and search misconception in electrolysis. You will come up with RSC resources on electrolysis and RSC paper on electrolysis. Read them. So that would help you understand these are the misconceptions. ASC also has misconceptions, which I recommend you to read before you teach electrolysis lesson to your class. It's very helpful. So, how is the electrolysis process? I also prepare my explanation using revision guides. I listen to videos and then I prepare my explanation. I try to keep my explanation very precise and concise, but it can alter, it never very, very concise and precise like I would have loved it, because the class environment, the class dynamic is constantly changing. So it is not exactly, although at home it does come, yeah, it's absolutely fantastic, but it changes because the class dynamic changes. So the misconceptions are included in the lesson plan. How am I going to now? Is the practice time. I want to give opportunity to practice what they have learned. So what I did for electrolysis, I gave them the definitions and I asked the students to draw the electrolysis process for me, to draw the cell for me, and label the diagram. I gave them the definitions. I introduced them to the word panic. I also provided my students with writing frame to help them describe the electrolysis process. So this was, I was promote. I see. Look, it's meeting teaching standard 3, where I'm promoting literacy, and you need to include in your lesson plan, and you need to practice this as well. Remind the students the time the activity will end. Constantly keep reminding the students. Uh, Next is apply the new content. Now we discussed about what is the electrolysis process, migration of ions. Can student now, I want to test, can my students now understand which ions will be positive ions, which ions will be negative ions, and therefore I have included this activity where the students need to understand the charges that will be formed and where the ions will be migrating. Now, students, as I've told you, keep telling you, it's difficult concept for them. So what I do is to scaffold it for them. I have a laminated sheet of 1 to 20 atoms and their electron structure. So it's drawn, and then I constantly question my students, what do you think? Will this atom lose or gain electron? So we come across such thing. So they have to look at the diagram and then understand, will it gain or lose and what type of charge it will form. Needs constant reinforcing though. If you're teaching mixed stability students, you can give them, um, you know, give them electrolyte compound and ask them where it will be determine the charge and where it will migrate. But if you have bottom set, then you need to scaffold this further for them, much further for them. um, you are constantly doing learning checks in your lesson. uh, for higher able students, you will have to teach half equation. There will be couple of higher level students in your class, so you will be teaching half equation. So I have included what I'm going to do in the half equation with my student. It's on my slide work also and in the lesson plan. The last bit that comes up is assessment for learning, AFL. For AFL, it's always good if you are able to show it if you get the whole class response, so you can use red, amber, green AFL sheets, or you can also use mini whiteboards, or you can ask students to draw in their book on each page, A, B, C, D, end of the book. And then you can ask them, is it A, is it B, is it C, or is it D? So they can choose a correct option and show it to you. So because it's either stuck in their books or it's drawn in their books in large font, you can use it as often, as you like, very quickly, suddenly. So it's always very handy. I find this handy more than mini whiteboards where we have to distribute the mini whiteboards. Or much more convenient is use of fingers, one, two, three, four. Like Dylan William also promotes it using fingers, one, two, three, four, but depends on your class and your relationship with your class. You can use finger method. So why are these questions for assessment? I have included why did I include these questions? It's to consolidate the learning, what we learned, so students can show us the answer. Pick up a student. Why did the student choose C, for example? What made student choose D? Pick up on students so you can discuss further on AFL. That helps. So students also find difficulty to understand between atoms, ions, and molecules. So I included such activity as an AFL. When you reflect on your lesson, you need to make sure you are reflecting on each learning outcome. Just what went well in this lesson, why is very broad question. It doesn't. So if you want to collect more evidence, you have to write your reflection in detail, and make sure when you write your reflection, in your reflection, you refer to each teaching standards. So, for example, now my first learning outcome, progress of student, identify ionic compound. So, activity included is written, and reflect on how students responded and what you could have done better. So, we have whatever I discussed with my student in the class, I wrote that down um, in the reflection. And then I'm also writing in my reflection, I keep referring to the teaching standard. So you're collecting your evidence, because many times you will not even receive observation forms from your mentors or teachers who come to see you. You do not receive, it can happen, you will not receive any learning walk notes and all, which can be very disheartening. So you don't have any evidence in the end. So it's better you have your reflections in detail, actually, where you are showing each teaching standard. You have to reflect on each learning outcome. So, for example, predict the product at each electrode for electrolysis of molten ionic compound. Activity was there. Reflect on how connect it to the activity, and then reflect on how students responded, how I could have done better. So here's my reflection, and I have set homework, because I understand that some students still do not understand concept of ion formation. How are ions formed? I understand that. So that is why I included it. I set it as a homework. So in your reflection, you have to write your reflection in detail and connect it with each teaching standard. So describe electrolysis with half equation. I understand. So I write my reflection. I also show that I had to go very fast on this activity, and I'm quite aware my students have not yet fully grasped this concept of electron, writing half equation using electrons, because they are not grounded till now in their for example, in their understanding of how ions are formed. So you can put that in your lesson reflection, that it needs more reinforcing. So more questions that you can write in your lesson reflections are: what problems did you experience and why? Was it student centered lesson? How you could have done differently? Preparation and research: what kind of research did you do um, making this lesson? uh, Presentation: were the students involved? Was your presentation clear? Assessment: how your assessment could have been better. So now you are checking teaching standards again. In your reflection, you're making sure that teaching standards are constantly referred back to, so you have evidence. What targets have you set for yourself? You should write include that in your lesson plan. That also goes as an evidence. If you have TA in the class, then ask TA to comment about your lesson. I have created resources that will help you evaluate your lesson, and that will help you in your PGCE and NQT. I hope you go through that resources, and do leave your comment if you want any guidance, or if you have any suggestions or any improvement for me. So thank you for listening.